Hello everyone. So previously we had discussed on the topic convex hull algorithm, right? So let's move on with this one. Today let's discuss on the topic closest pair of points algorithm. Yeah, let's see what the definition part say here. Let's get into the definition part. So see here, the closest pair of points problem finds the 2 points in a 2D plane, similar to the this one convex hull algorithm itself, right? That are closest to each other based on their Euclidean distance. Based on their, this is very important. Based on what? Based on their Euclidean distance. So this is very important. It's an important computational geometry problem that is solved efficiently using the divide and conquer technique. One thing you have to know the divide and conquer this one algorithm, and another one is you have to know how to calculate the Euclidean distance. Yeah. So this one we know. We have already discussed this one. I'll be explaining while I write the algorithm. No worries, right? So first let's get into the explanation part. Listen to this carefully. The exact same thing will be articulating in the form of code or will be implementing in the form of code, right? So a naive or the straightforward approach here compares every pair of points taking big of n square time, right? The naive approach compares every pair of points nothing but taking big of n square time. But with divide and conquer, we can reduce the complexity to big of n log n. But with divide and conquer, we can reduce the complexity to big of n log n. Yeah. So that is one of the advantages. Yep. So naive approach, big of n square time, divide and conquer, we are reducing the time complexity to big of n log n. So what are the steps of this one closest pair of points? I'll go here. Let's discuss the same. First, uh, this one, first what we'll be doing, we'll be going with a sorting. What we'll sort? We'll sort the points based on their x coordinates. Yeah, just remember this. We'll be sorting the points, no doubt, but based on what? Based on the x coordinates. Yep. So then the second point here is divide the set of points into two halves, right? So we will divide the set of points into the two halves. One is left and another one is right. Right. So this is fine. Yeah. After dividing the set of points into the two halves, what we'll do, we can recursively find the smallest distance in each half. That we can do, right? So we can just go with a, we can recurse or we can just go with a recursion actually to find the smallest distance in each half, right? Sort, divide the set of points into two halves, recursion, then finally, as we have two halves, we'll combine the results, meaning we'll check for the closer pairs that lie across the dividing line using a strip region, using a strip region. Yeah. So we'll return the minimum of all the distance that we have found, all the distance that we had found. Yep. So this is fine. So we'll go with the minimum in simple terms. Yep. So this is it for the explanation part. Exact same thing, whatever we discussed in the explanation part, let's articulate in the form of code, right? So let's go step by step. Let's start with the this one, importing math actually. So I'll just import math here. So this is fine. Next, let me go with a function named distance. Just go with P1 and P2 parameters here, right? So what I need to return here, so I have important math because I want to make use of the square root. So I'll just go with square root here. This is fine. P1 of 0 minus P2 of 0 to the power of 2 actually, to the power of 2, right? So this one I can just write it in this way, to the power of 2, then less p1 of 1, p1 of 1 minus p2 of 1 minus p2 of 1. So this is also fine, uh, to the power of, to the power of, yeah. So this is fine. Next, let's go with a brute force method for small set of points, right? So I'll just go with a def here, mm, brute force, yeah. So I'll just go with a points as parameter. Now, within the brute force function, so I'll be making use of the points, length of the points everywhere. So let me assign this one to the variable n, right? So I'll just go with len of, let me pass the points here. Sorry, 1 second. Sorry, just go with points. Yep. So this is fine. Next part, I'll just go with the minimum distance. Let me assign this one to the float of initially. Let me set this one to the infinity. Yep. So next, let's move on with the for loop for I in range. Sorry, not raise actually. In range n, right? So within the for loop, the first step would be, so we need one more for loop, right? So I'll just go with for j in. We are considering in 2D plane actually. Yep, so this one I'll just go with a for j in range. So I'll just go with I plus 1. Along with the I plus 1, I'll go with the n. Yep, so this is fine. So within the for loops, so let me assign d to, let's recurse, or let's do one thing, like, let's make use of the distance here, the first function that we have written, right? Distance of this one, points of I and j, right? So I'll just go with points of I, comma, points of j actually, points of I and points of j. So let's write the simple if condition. If d less than minimum distance, nothing but min d, then what we'll do, I'll just assign minimum d to the this one. What do we call d, right? So minimum d to the d, right? So this is fine. Yep. And one more thing. Finally, let's return the min d, right? Minimum distance. Yeah. So we are done with the coding part actually. Sorry, we are done with the writing brute force function actually. Next, let's do one thing. Let's write the function to find the minimum distance in a strip of points, right? So I'll just go with f. Yeah, I'll just give strip closest. So I'll just go with the strip as well as the parameter strip and d I need. So minimum distance, let me set this one to, or let me initialize this one, assign this one to the d. So this is fine. Let's sort the strip points by y coordinates for optimization. So this is just for the optimization purpose. I'll just go with strip dot sort. This is not showing. Okay, let me write this one. Let me set this one to, sorry, key equals lambda. This is fine. Mm, and let me go with p based on p of 1. Right, so this is fine. The next step would be, let's move on with a for loop one. For loop for I in range. What's the range here? So length of the strip, right? Strip dot length actually. Length of the strip. So this is fine. The next, sorry, let me give colon here. So within the for loop, so let me assign j to I plus 1. Yep. Now let's check the next 7 points only, right? So this is the geometric property. So for that, let's go with a while loop here. While j less than length of strip, nothing but the strip length. So, and one more thing, I'll just go with the strip of this one j as well as 1 minus strip of this one I1. So this one I as well as the 1 less than min d, right? So min d. Within the while loop, I'll just set the min d to the minimum of min d, this one. Also, let me go with distance of this one. Strip of I, strip of I, comma, strip of j. Right? So strip of j. So this is fine, I believe. Strip of j. Yeah. Next, let's set the j equals j plus 1. So let's set j equals j plus 1. Finally, we have to return the minimum distance, right? So this one, yeah, I'll just return minimum distance or min d. So this is fine. We are done with the strip closest a function, right? So now let's go with a recursive function to find the closest pair distance. I'll just go with a function named closest util, nothing but the utility function closest util, right? So I'll just go with def closest here util. So let me pass the parameter one as points actually. Yep, point. I'll just set this one n equals length of point. So this is fine. The next one, if n is less than 3, if n is less than or equal to 3, then what we'll do, let's return. Hmm, let me make use of the brute force function here and let me pass the points. Let me pass the points. Yeah, so this is fine. So next, let's go with the mid actually. Let me set the mid to n by 2. Yeah, let me set the mid to n by 2. Also, let me consider here midpoint. Midpoint, let me set this one to the points of mid. Points of mid. Yep, so this is also fine. Then let's go with the DL, DR, and D. DL, let me assign this one to the closest util of this one. Let me go with points of mid actually. Points of mid. So dr, let me go with again the closest util here. So this one will be points of mid actually. Points of mid. This one, let me do one thing. Let me mention colon here. This is fine as well. Final one is we have to take the minimum, right? So min of DL and DR accordingly with what we discussed in the explanation part actually. DL comma DR. Right, so this is fine. Next, let's do one thing. Let's build the strip region. Let's build the strip region. So let's do one thing here. Let's build the strip region where x minus mid x is less than d actually. So I can just write it in this way. Where is strip actually? Let me consider strip here. So this one b for b in a range actually. Sorry, not range actually. Let me go with the points here. Sorry, points if absolute of p of 0 minus midpoint actually. Let me consider this one of 0, midpoint of 0 as considered less than d, right? Less than d. So then let's return here. What we need to return? Minimum of d and let me pass the strip closest here. The function that we wrote just now. I'll just pass the strip along with the strip. Let me pass the d. So this is fine. So we are done with the closest util helper method of the function as well. Now let's go with the main function or the last one, nothing but closest pair, the algorithm closest pair of points itself, right? So I'll just go with closest pair, right? So closest pair, let me pass the points here, right? So within this function, let's sort the points based on the x coordinates before recursion. So this we have discussed in the explanation part. So I'll just go with the points dot sort. Let me go with lambda. So because we have to sort this one based on x coordinates, right? So this will be p of 0. Yep. Final one is let me return here. What we need to return? I'll just go with the closest util of points. So let me pass the points here. Yep. So this is fine, I believe. The final part, we are done with the algo. This is it for the algorithm actually. So we have made use of many helper methods here. First thing is distance. This one brute force. The third one is a strip closest function or the helper method. Fourth one is closest util, nothing but the utility. The final one is this one, closest pair actually, closest pair. Right, so this is fine. The next one is let's go with the example input. So I'll just go with the points equals this one 2 comma 3. So this one is fine. 12 comma 30. So this is also fine. The third one is 40 comma 50. This is also fine. And the fourth one is 5 comma 1. 5 comma 1. So this is also fine. Next, let's go with 12 comma 10 actually. So this is also fine. The final one is 3 comma 4. Yeah, 3 comma 4. Let's go with the final one print. The smallest distance. The smallest distance is, so I'll just go with, let me call the closest pair here, the main function, closest pair of, let me pass the points here. Let me pass points here, right? So this is it for the algorithm. So we have discussed this one step by step, yeah, along with the example usage at the last, right? So let me explain this one once again so that we don't forget, and then we can just run the code and discuss the output. Yep. So here, first thing, we are just going with the distance or the dist function. So dist of p1 comma p2 parameters, right? So basically, as we had discussed in the explanation part, so this calculates the Euclidean distance between the 2 points p1 and p2. Yeah, next we are going with a brute force function. Brute force function or the helper method, it is used when less than or equal to 3 points remain actually. It checks all the pairs basically. Yeah, so this is fine. But then what does the strip closest function or the helper method do here? We have considered strip and ds parameters, right? So this function filters and compares points near the middle boundary. Yep, near the middle boundary. So this is important. Yeah, next let's move on with the closest util. Closest util of points, basically its main core logic here is to go with the divide and conquer, right? Divide and conquer recursion actually. Divide and conquer recursion, right? It divides the points at midpoint and it recursively finds the closest distance, left nothing but dl and right nothing but dr. Dl and dr, we have made use of dl and dr here, right? So this one. Finally, it combines the result using the strip method. It combines the result using strip method, line number 62. Next, final step is this one, closest pair function actually. We have considered the parameter points here. Basically, what it does, it sorts the input once by x coordinate for the recursion efficiency. That's what we have done here, right? Sorting based on the x coordinates basically for the recursion efficiency. Finally, we are printing the minimum distance among all the pairs. So we are going with the example usage, this one actually. Also, we are going with the this one example usage. Yeah. So let's do one thing. Let me run this one Python followed by the this one file name dot py, right? So I'll just copy this one. Let me paste it over. Right, so that the smallest distance that we are getting here is 1.4 something, right? 1.4 ending at 5.1, right? So basically what is happening here, let me explain you this one. I should have explained this one before itself with the output. So let me explain you this one. The closest pair here are accordingly with the output. Just give me a second here. Sorry, input. Basically, what's the input that we have considered here? See, we have considered 2, 3, 12, 30, 40, 50, this one, 5, 1, 12, 30, and 3, 4. So by looking at it itself, by looking at the points actually, x and y coordinates, the closest pair are here, this one, 2, comma 3. You can just say it, you can just consider this one by looking at it itself, right? So one is 2, comma 3 and 3, comma 4, right? So the closest pair here, let me write here CP, nothing but the closest pair. Closest pair here are 2, comma 3 and 3, comma 4 respectively. 2, comma 3 and 3, comma 4 respectively here. Their distance is calculated by the Euclidean distance, P1 and P2, right? So this we will be considering as P1 and P2. For that, we have written the helper method dist at first itself, right? So this one, their distance D, nothing but ED. Let me write this one ED, nothing but Euclidean distance. So this one will be square root of uh, 3 minus 2 whole square. So this one, these two and these two. Then first this one, 3 minus 2 whole square. So first we will be going with the 3 minus 2 whole square plus this one. Now this one, 4 as well as the 3, right? If you know the Euclidean algorithm or how to calculate the Euclidean distance, 4 minus 3 whole square, right? 4 minus 3 whole square, right? So this will be equivalent to 3 minus 2 whole square is nothing but 1 square, right? 1 square plus 4 minus 3 whole square is nothing but again 1 square, right? So this one, 1 plus 1, it will be square root of 2. It will be square root of 2. Square root of 2 will lead us to the output, this one, 1.41 something actually. You can just check square root of 2 actually. It will be 1.4142 goes on actually. 1.5 something. So this much, right? So this is the output that we need to get. The closest point, 2 points, P1 and P2, accordingly with the code actually, this one, 2, comma 3 and 3, comma 4. Then we are going with the Euclidean distance. So we get square root of 2. Square root of 2, when we do the square root of 2, actually, it will be 1.4, 142 goes on. So this output that we need to get basically, right? So the output that we got here is this one, which is equivalent to the output that we have got when we ran the code actually. So this works. We are getting the desired output. The algorithm, we have written the algorithm correctly, right? So algorithm works fantastically here. right? Flawlessly, basically. Yep. So this is fine. Now we are done with the algorithm part. Yeah. So we are done with the algorithm part. So basically, what I'm trying to say here is we are done with closest pair of points algorithm. So let me summarize whatever we have learned so far. So just try to remember these 3 or 4 points. These are very important. You have to know this one at any cost, right? First one is, so brute force function, we have made use of brute force function in the algorithm. So brute force takes big O of n square actually, right? Brute force takes big O of n square and divide and conquer reduces. So we have made use of the divide and conquer as well, right? Divide and conquer reduces this one to the big O of n log n. Brute force takes big O of n square and divide and conquer reduces this one to the big O of n log n, right? So this is the first point. So this one you have to know. Why we will be going with this one closest pair of points usually. So divide and conquer reduces this one to the big O of n log n. Yeah. So next, what are the steps actually? First, we will solve. Yeah, this one we have already decided, discussed actually. First we'll be going with the sorting, then divide, right? So then divide. After dividing, so we went with the recursion actually, right? So then we went with recursing actually. I'll just write recurse here. Finally, combine. Finally, what we did, we combined, right? Finally, combine. Nothing but here strip check. Nothing but strip check. Yeah, so let's move on with the third step here. Third step, nothing but we made use of the Euclidean algorithm, right? So Euclidean distance, sorry, we made use of the Euclidean distance here and geometrical optimization, and we can just call this one as geometrical optimization or geometry optimization, meaning we are checking only 7 nearby points in the strip, right? So that is nothing but the geometry optimization. We went with the Euclidean distance and geometry optimization, right? Only checking 7 nearby points in the strip. So this is one of the important points. The final one here is this one. This is most efficient approach for the large point sets, right? Large point sets. It is most efficient approach for the large point sets. Yeah, just remember this one. Yep, so this is fine. So we are done with the algorithm part. We are done with the algorithm part, right? So this is it for the closest pair of points algorithm. Next, what we'll be doing, we'll be continuing with the rotating calipers algorithm, right? For now, this is it. Thanks for watching, guys.